Hello everyone, welcome back to my channel. To those who are new here, my name is Madonna Sizwe and I am a student teacher who is very passionate about helping young individuals who are doing engineering, graphics and design as their school subject. In today's video, we are going to talk about things that are really simple but very important when it comes to technical drawings, which is line types, which is orthographic projections, and also we are going to talk on how we use different scales in EGD. And also there will be demonstrations while I explain some of those things. So if you are new here, please don't forget to subscribe and please don't forget to hit that like button. Okay, starting with orthographic projections. Have you ever looked at a technical drawing and asked yourself how engineers understand those lines and shapes? Before we can move into the differences of our orthographic projections, I want to explain orthographic projection, what it is and why is it important. Simply, orthographic projection is a method of representing our 3D objects, meaning something like this as an object. We are representing our 3D object in 2D, meaning you are drawing something from different angles like the top, the front and the side. Okay, so that someone can understand exactly what it looks like. And then orthographic projections are important because they show all the details of an object. Okay, so moving to our differences here, I've written a summary of the differences between first angle projection method, also the third angle projection method. The difference number one is that in first angle, our object is kept in the first quadrant. If you are familiar with the quadrant, as you guys know, we only have 4 quadrants, which are this, which is quadrant 1 on our top right, quadrant 2 on our top left, and then we have quadrant 3 on our bottom left. Then the last one is quadrant 4 on our bottom right. Okay, meaning here they say the object is kept in the first quadrant, meaning our object will be placed on this quadrant, which is the first one. Okay, then in the third angle, the object is kept in the third. So in EGD, we only use 2 quadrants, which is this quadrant and this one, which is first angle and third angle. And then on first angle, our front view is always above top view. Our front is always above top view. And then in our third angle projection method, the front view is always at the bottom of top view. Please guys, get those things right. Front view is always at the bottom of top view in third angle, and in first angle is vice versa. Front view is always above top view. Okay, moving to the side views. The right hand view is drawn to the left and left hand view is drawn to the right, meaning you swap the sides. If you look at a drawing from this side, which is the left hand side, we're gonna draw the left hand side on this right hand side. That's what they mean there. The left hand view, which is we are viewing from this side, we are going to draw our view on this right hand side. And then if you are looking from the right hand view here, we are going to draw our right hand side on our left hand side. Okay, then the right hand view in third angle is drawn to the right and left hand view is drawn to the left. So in third angle, whatever that we see from our right, we are going to draw on the right view, and then whatever we see from our left, we are going to draw it on our left view. Okay, so the last difference is the projection symbols that are used. Okay, I am going to help you on how to identify the different projections if you are not familiar with them. This thing is a cone. It was a full cone, and then it happened to be cut here, so it is now called a truncated cone. This is the truncated cone that is used to represent the different projection symbols. Here, when you look here from your left, since they said here the right hand view, which is from here we are looking at the left hand view is drawn to the right, meaning if you are looking from the left, we are going to draw on the right hand side, okay, which is what you see on here. And then if you see this line here, just indicate like this here, you will know that this is first angle. Indicate it like this. And then moving to third angle, if you are looking from our left, which is this is our left, if you are looking from our left, we are going to draw on our left, you see. And if you see a circle starts before this cone here, truncated cone, we can simply do something like this here. Can simply do something like this to have an idea that this is a third angle orthographic projection. And then here you can simply do this one, you can draw one here to represent first angle orthographic projections. So now I have prepared a drawing as to demonstrate and show you how we place our views if you are given a solid drawing, which is isometric drawing, and then they require you to draw a front view, a top view, and a side view using either first angle and third angle, which is on this box here. We are going to draw a first angle with this drawing, and then on this second box we are going to draw a third angle projection with this object. Okay, so I have indicated A as my front view. So in first angle, they said that front view is always above top view, meaning if this is going to be top here, meaning our front view is always going to be here. Always. Front view is always above top view. Okay, then the right hand view, meaning if you look from here, if this is our front view, if you look from here, whatever that we see here, we are going to draw it on the side. This is going to be our left view, okay, and then this is going to be our right view. Okay, only the front view can guide us. Okay, then on this line on here is going to be our 45 degrees angles. We use 45 degrees angles to align our drawings accurately, guys. Don't be surprised. We use our 45 degree angles to align our drawings accurately. This is our 45 degree angle on this side. Also here is our 45 degrees angle. So since I have indicated that A shows us a front view, meaning this is going to be our front, this is going to be our right here, looking from this side, and looking from that side is going to be our left. Okay, then looking from the top here, it is going to be our top view. So we need to start on our front view. Okay, let's start on our front view. The distance between here on our front view to here, because we are only going to see this side, we are not going to see this side on front view. We need the distance from here to here, and also need the height, which is the distance from here to here is 25, which you can simply measure with your set square. 0, 25. Then perpendicular to XY line, construct your line, vertical line, and then they give you a height of 20 to the top side, and then a measurement of 10 from the top side. So let me use my different markers so you guys can understand. This side is 1. Let's call this 1 with a yellow marker. 1, which is our front view. And then with a blue marker, we have 2 as our top view. And then with a brown marker, we have 3 as our side view. So we're gonna need to take this measurement and convert them here. So this 20, we are going to feature it here. 0 from here, 20. And then from the top side, they said from here to here is 10. We need to say from here to here 10. We are going to do a construction line also. Construction line where our height ends. And this will be our front view. This is how our front view is going to look. It is very important, guys, to understand these things. This is 1, also this is 1. And then from our front view, that's when we can feature our side view and our top view. Let's look at our top view. From our top view, we can also see that we have this 2 here. We are also going to see this as our top view. So we are going to see these 2 parts here. And then from here, the back side to here, they give us a measurement of 15. And also they give us a distance from here to here, which is 15, meaning the total distance from here to here is going to be 15 plus 15, which is 30. So we are going to measure from here 15, from here 30. Okay, this is what we are going to see from there. This is the top view. Okay, and then this is the same distance, guys. 25 applies here on this lines here. You see 15, also 30. Okay, then you are going to do your continuous thick lines on the outside edges, also here, which is going to be 2 here, 2 here. This is our top view, guys. Top views, we are going to see this and this. And then moving to our right and left view, we will need to project these measurements to our 45-degree angle. We will draw our top view, our left view. So we just need to project your lines horizontally, so to the left side, to the right side, because our left we are drawing on the right side. Then as soon as they touches your 45-degree angle, because you want to align this properly, you construct them vertically upwards. Extend this one until here, and then as soon as it touches this one, you construct it vertically upwards. And then looking from this side, which is our right view, which we are going to look on that side, from that side there, which is going to be our left view, which is we are going to draw it on this side, meaning from here to here it is going to be a solid line, which is this line on here. We are going to look at the drawing from this side, which is going to be this line. We also have a height like this one from here to this point. So when we are on this point, we are just coming straight with a length of 15, which is this length here. We are going to come here straight. We are going to come downward straight, and then when we reach here, we are going to our last point, which is this one here. It is going to look like this. This is how it our left view is going to look like, which is number 3. And then our slight angle, how we place our views, they said our front view is always at the bottom of top view. Front view must be at the bottom of top view, meaning our top view is now here, and then this is now our front view. Remember, front view goes with our side views, meaning our side views are now going to be at the bottom also. Okay guys, that's the only differences you need to know when it comes to orthographic projections. No, we are going to do our 45-degree angles on the top side. Now we are going to do our 45-degree angles on the top side here. So now we need to draw our front view. Our front view is still going to look the same as this one because our A is the one that is representing our front view. So we can take construction lines from first angle projections, that side you can say. Okay, our front view, parallel line to XY here, just 25. Confidently so with a solid line. And then our front view have a height here from here to here, which is 10. Also they give us a height of this thing from the bottom to the top side, which is 20. So you now know we need to measure from here, which is 10. Also need to measure from here to here, which is 10. It gives us a full length of 20. Okay, which it gives us a full length of 20. Yeah. So this is where our first 10 is going to be. Confidently so with a solid line, and the bottom here confidently so with a solid line. Okay, so looking from our drawing, we have this bottom part here on front view. This is 1, also this is 1. Okay, then from our front view, you can now project our top view, which is 2 and 2, and then you can also project our left view and right view, which is 3. Okay, then on our top view, we still use the same measurement. From here to here is 15, and then also from here to here is 15, meaning the measurement from here to here is going to be 30. So we will need to use this measurement from here to here is still 25. So confidently so you can construct our 25. Then from here we are going to the back, we will need to use 30. Your method is not going to fit in here, but I will do it. I will force it until here, guys. But we now have an idea of how this thing is going to look like. 015. Now it's going to include my name here. But yeah guys, if you have an idea, this thing is going to be very simple for you, because also this is still top view. We are going to use color number 2, which is top view here. Okay guys, then from our top view we can construct a right view, and then project our points to our 45-degree angle first. Project them to 45-degree angle. Also this one, we project it to 45-degree angle. Then you now construct them. Vertical downwards to your right hand side here, which is going to be our right view. Okay, then you need to align them with the constructions from our front view here, and here. So now looking on our right view, we are going to see that part there, which is number 3. So on our top, we are going to see we have from here to here, right? And then we have from here, because when we are here, which is at the front here, guys, this is at the front, which is at the front here, going at the back. This is at the front, going at the back. From front, you need to come here, remember. Okay, So front, we are coming here, which is here on this point, which is going to be on this point. Okay, so now I can take my set square confidently. So using my solid line, I can construct my object like this. This is how my right view is going to look like. This is set number 3. Okay guys, that is how we differentiate our orthographic projections. Please keep this in mind. Orthographic projections are very important for you guys to know. And then looking at your bottom right corner, you see that how we place our view, our objects in the first and third quadrant. Okay, now moving to type of lines and scales. It is very important to learn the different type of lines because different lines means different things, and knowing them is important as you need to understand and create proper drawings. Line types are very important because they help us make a drawing clear and easy to read, because without them people get more confused and build something the wrong way. Think of a line types like texty, because when you text someone you use capital letters, emojis, and punctuation, and they all tell you something extra. Okay, so even in EGD, line types do the same. So here I'm going to do with you different line types. Here are the most common line types. Okay, we have a continuous, we have a dashed, we have a center line, and a thin solid. Okay, these line types do not end here guys. There are also, these line types do not end here guys. If you look at your bottom right corner, there is a picture of different line types and their uses. Okay, also on your bottom left corner there is another picture. I will share them on my comments so that you can get access to them. Okay, now I'm only going to do a demonstration of how these line types look. Okay, starting with continuous line. A continuous line is a line that shows us the visible edges, meaning we can see them. It's like the visible edges. Let me show you. The visible edges on this shape will be the outer lines. Okay, this will be the visible edges. Okay, this is how you draw a continuous line with a thick solid line so that we can see it. Okay, and then we have a dashed line. A dashed line is a hidden detail line. A hidden detail line, it shows us the parts that we can't see from the outside. Okay, let's say if we had something inside of our object like this, and then maybe it was a circle, and then on our front view, because this is solid, we will never see that circle inside. Okay, so we were going to use hidden detail lines, which is dashed lines. Okay, you can see from here on my drawing. Okay, and then this is how you do your dashed lines. Okay, then we now have a center line. A center line is the one that shows the center of the circle or symmetrical parts. Okay, and then how we do a center line, you do a long dash, small dash, long dash, small dash, long dash, small dash. Okay, and then we have a thin solid, which I call it a construction line. It is used for guiding us. This is a construction line. This is how you do it. Thin line. This is the type of line that is mostly used in drawing because it guides us. in every topic we always use this line. Okay, then here on my drawing that I created, I wanted to show you this different type of lines that we just did here, which is the visible edges I was talking about. I was talking about this one. We use our continuous line to show these edges, and then we used our hidden detail, which is dashed, to show the hidden part, meaning if this thing is solid, we cannot see that cylinder inside. We can only see the circle here at the top of the cylinder. We have the bottom of the cylinder there, which is also a circle with hidden details. Then you have a center line showing us the center of the symmetrical parts, which is the circle at the top and the circle at the bottom. This is the center of the circle. This is the center lines. Okay, then thin solid lines are the ones that guided me to complete this drawing, which is the construction lines. Okay, now moving to our scale. I believe scale is used in EGD because we want to produce correct proportions. And talking about scale, I want to tell you that it is very important to use scale when drawing, because in real life objects can be too big or too small to draw them with their actual size. That's where our scale comes in. Okay, and scale allows us to make drawings bigger or smaller, but still in the correct proportions. Scale is important because everything fits together when it's built. So a good scale that's drawn on a paper matches what's made in real life. Okay, so here I made an example with a rubber. So here's my rubber here. I wanted to show you how we use scale. So if my rubber fits here, it means the measurements of this rubber are exactly, meaning the scale that is used here is K1 is to 1. Okay, and then when we come to this drawing, we can see that this drawing is bigger than this rubber, meaning the measurements were enlarged. You see, so the scale that is used here to enlarge is 2:1. Then when you come on this drawing here, you can see that the rubber is bigger than the drawing here, meaning this is not an actual size. Okay, so the scale that is used here is 1:2. Okay, let's assume that this measurement here is 60 for the actual size of the drawing and the rubber. This measurement here is 60, and then on this drawing here, the measurement here again, it will be 60, to show you that 60 was multiplied by 2 to get the length of this rubber here, which is 60 multiplied by 2 is 120. Okay, and then on this drawing here, it is also going to be 60 here. Okay, because this is smaller than our rubber, meaning the measurements were halved by 2. Okay, they were halved because our scale is 1:2, and then here our scale is 2:1. If you see 2 at the front before 1, meaning you multiply, and you divide by 2, you multiply by 2. Okay guys, that's the end of our today's session. And please, if you find today's video very helpful, don't forget to subscribe and don't forget to like this video. Thank you for your time.